This video is to introduce the topic of linear inequalities in section 6.4 of Math 120. When we're trying to solve linear inequalities, we solve by using all of the same steps we would to solve linear equations. But there's one exception or one difference, and it's when you multiply or divide both sides of an inequality by a negative number, you have to switch the direction of the inequality symbol. So first things first, let's review what those inequality symbols are. This symbol is our greater than symbol, and this one is our less than symbol. You can take both of those symbols and put a line underneath them, and that line represents equal to. So this one on the left-hand side says that it's greater than or equal to. It can be either one. And same thing over here means less than or equal to. So let's talk a little bit about what happens with those negative numbers. Say that we started with an expression like 1 is less than 3. Right? That is a true statement. 1 is less than 3. And if we're supposed to be able to follow all the same rules of solving equations, we should be okay to do the same thing to both sides of this, and it should still be true. So say that I multiply both sides by 2. If I do that, 2 times 1 gives me 2, 3 times 2 gives me 6, and if I bring down my less than symbol, I still have a true statement. 2 is less than 6. So say I start with that same statement. 1 is less than 3. But this time, I multiply both sides by negative 2. If I do that, negative 2 times 1 gives me negative 2, and 3 times negative 2 gives me negative 6. If I just bring down my less than symbol, I end up with a statement that is false, right? If you think about your number line, with our negative numbers, negative 2 would be right here, and negative 6 would be right here. Negative 2 is not less than negative 6. So for that reason, when we multiply both sides by a negative number, to make this a true statement, we have to flip that inequality symbol and say that negative 2 is less than, or I'm sorry, negative 2 is greater than negative 6. The same thing happens if we divide both sides by a negative number. Right? If I start out with something like 8 is greater than 4, still a true statement. If I decided to divide both sides by negative 2, I would have negative 4 and negative 2. If I just brought that inequality symbol down, I still end up with a false statement. Negative 4 is not greater than negative 2. So what we do is flip that inequality symbol around. Now, when we're solving inequalities, we usually graph our solutions on a number line, because with an inequality, there's more than one answer. So if we look at this first example, x is greater than 3. X is being compared to 3. So 3 absolutely has to be on the number line. Then I usually surround that number, whatever we're comparing the variable to, with a number that's 1 smaller and 1 bigger on the number line. Now on our number line, we always put some sort of circle on top of the number that's being compared. If we're saying that x is greater than 3, x cannot equal 3, because then 3 is not greater than 3. So what we do to represent that is put an open circle on top of 3. And if we want all of the numbers that are greater than 3 or bigger than 3, we want all the numbers to the right of the number line. So we draw an arrow to the right of 3. That is how we represent our solution on the number line. If we look at this one underneath it, x is greater than or equal to 3, it's almost exactly the same. I'm still comparing x to 3, and I still want all of the things bigger than 3. So I still want my arrow to go to the right of 3. The difference is that equal to, that line underneath. This time it's perfectly okay to say 3, because 3 is equal to 3. So we still put a circle on 3 on the number line, but this time we make it a closed circle. We shade it in. So that open circle up here means that it can be really, really close to 3, but not actually equal 3. Down here, where we have our closed circle, we're saying that x can actually equal 3. So if we look to the right, where we have x is less than 3, we still need 3 on the number line. And for this one, where x is less than 3, we still need our open circle because we don't have that equal to. But less than is all of the numbers to the left. So if we have x is less than or equal to 3, we'll still want a circle on 3, but this time, because of that equal to, it's going to be a closed circle. And less than is still telling us to shade to the left.